I want to illustrate computing integrals of two variables using Wolfram Alpha. As our problem, we're going to assume that x and y have this joint density, 2x plus 3y, where both x and y fall between 0 and 2. We first ask, is f a legitimate density? Second, once we check that out, then we want to find the probability that both x and y are bigger than 1. And third, we're going to find the marginal densities of x and y. To see its legitimate density, we want to make sure that the total integral of this density is equal to 1. Both x and y fall between 0 and 2, so we want to find the integral for the volume over this rectangular region. So I'm going to use Wolfram Alpha. So I've already entered in the function we want to integrate. First variable is x, goes from 0 to 2. Y goes from 0 to 2, and we compute. And we see that our answer is 20. So this is not integrate to 1. But if we divide the integrand by 20, that will integrate to 1. Okay, next we want to find a probability. In this case, the probability both x and y are bigger than 1. This is, we want to find the volume of the surface over this rectangular region where x and y are between 1 and 2. So we'll go back to Wolfram Alpha. First, I'll correct the function so it does actually is a PDF. And then I want x to go between 1 and 2, and y to go between 1 and 2. And Wolfram Alpha tells me that this probability is equal to 0.375. Okay, last thing we want to do is we are interested in finding the marginal densities of x and y. To find the marginal density of x, we want to take the joint density and integrate out the variable we don't care about, which in this case is y. Likewise, we want to find the marginal of y. We want to take the joint density and integrate out x. We can find those by using the regular integral calculator in Wolfram Alpha. So I've already entered in the joint density function. If we want to find, we want to integrate out y to find the marginal density for x. So y will go between 0 and 2, and we compute. And this tells me that the marginal density for x is 1/10 2x plus 3. In a similar fashion, if we're interested in finding the marginal density for y, we want to integrate out x between 0 and 2. And this tells me that the marginal density for y is 1/10 3y plus 2. So we see that Wolfram Alpha is a very useful tool.